All right, so Gödel agents, huh? AI systems that can rewrite their own code to get smarter. Sounds like something out of science fiction. Let's deep dive into this research paper, shall we?
Yeah, it really does. And in a way, it is. To get this, we need to glance back at the Gödel machine.
Okay, back up for a sec. Gödel machine.
Right, so think of it like this, like a theoretical blueprint for a self-improving AI system. This thing, this Gödel machine, could learn, but not just that, it could also change its own programming to become more efficient. Pretty wild, huh?
Wow. Okay, so that's the Gödel machine. But this paper is about Gödel agents. What's the connection?
Gödel agents are like taking those theoretical principles and putting them into action. They're all about building AI that's super adaptable and crazy efficient.
Got it. So less theory, more practice. Right. So let's crack open this paper. What are the core components of a Gödel agent?
Well, at their heart, they're learning algorithms, driven by what we call a reward function.
Reward function.
Think of it like training a dog. You give the dog a treat when it does a trick, right? That's the reward. Well, a Gödel agent gets a reward when it successfully completes a task.
So it's learning through trial and error, trying different things, getting feedback based on how well it does.
Exactly. And here's the key. It can actually change its own code based on the rewards it gets, constantly analyzing itself, tweaking its programming to become more efficient.
So it's basically an AI that's constantly learning and evolving. Kind of scary, no?
That's where the idea of boundedness comes in. Researchers they're looking into ways to control how much these agents can change their code.
Okay, good. So we don't have AI systems running amok.
Yeah.
But how do we actually put those boundaries in place?
Well, there are a few approaches. One is something called resource bounding. Basically, you limit the computational resources it has access to, things like processing power or memory.
So you're giving the AI a limited budget. It can only make so many changes before it hits its limit.
You got it. Another approach is action bounding. You restrict what actions the agent can take in its environment.
So we're setting limits on what the AI can actually do, as well as how much it can change itself. It's a multi-layered approach to safety. What else?
Then there's performance bounding. This ties the agent's ability to modify its code directly to how well it's performing. If it's doing great, it's got more freedom to experiment. But if it starts messing up...
You take away its coding privileges. It's like a reward system with built-in checks and balances. Smart.
Precisely. Now let's talk about training. This paper gets into some pretty intense techniques. One of them is using evolutionary algorithms.
Okay, remind me how those work again.
So imagine you have multiple versions of the agent, each with slightly different code. You set them all loose on the same task, and the ones that perform the best, they get to reproduce. Essentially, they pass on their code modifications to a new generation of agents.
So it's like natural selection, but for code. The most efficient, the most effective versions survive and evolve.
That's the idea. And this process allows these Gödel agents to find solutions that human programmers might never even think of.
So we're not just talking about making AI smarter. We're talking about finding completely new ways to solve problems.
Exactly. And this paper shows them tackling some pretty complex stuff, from optimizing sorting algorithms, which, by the way, are used everywhere in computing, to solving complex reasoning problems. They even use them to, get this, optimize radiation therapy plans.
Wow. AI helping to fight cancer. That's incredible.
It really is. And this is just the beginning. The potential applications are, well, almost limitless.
All right, before we get too carried away, you mentioned earlier it could get scary. What are some of the potential downsides?
The biggest one is, unintended consequences. What if an agent changes its code in a way we didn't anticipate? It could lead to something unexpected, maybe even harmful.
Right. Even with all the safeguards, things could still go wrong.
Yeah.
So how do we make sure these AI systems stay on the right track? That they're actually beneficial?
That's the million-dollar question. And it's why researchers are so focused on building in those safety measures and ethical considerations. We have to think not just about what these Gödel agents can do, but what they should do.
Well said. Okay, we've got a good grasp on the basics. What are some of the specific techniques they're using to actually build and train these Gödel agents? What jumped out at you from the paper?
One thing that caught my eye was the variety of ways they're tackling that boundedness issue. Making sure the AI doesn't rewrite itself in a dangerous way. They really delve into the nitty-gritty of different methods.
Okay, let's break those down one by one. Where do we start?
Let's start with resource bounding. That's where you put a limit on the computing power and memory the agent has access to.
Right, like giving it a sandbox to play in. Make sure it doesn't go off and build a robot army.
Yeah.
Smart. What else?
Action bounding. This is all about limiting the specific actions the agent can take within its environment.
So controlling what it can actually do, not just how much it can change itself. It's a multi-layered approach to safety, which makes sense. What else have they got?
They also talk about performance bounding. This is where you tie the AI's freedom to change its code directly to how well it's performing its task. If it's doing well, it gets more leeway. But if it starts messing up...
Take away his coding privileges. You're saying, hey, AI, you can try new things, but don't screw up. Fascinating.
Exactly. And that balance is key. We want them to be innovative, but we also need them to be careful. But these bounding techniques are just one piece of the puzzle. This paper also looks at the bigger picture, the potential implications of this technology, and how they're trying to address those in their research.
Okay, let's talk about that, because I think a lot of people hearing about self-rewriting AI are probably thinking, hold on, what could go wrong? What are some of the concerns they bring up?
One of the big ones is, well, unintended consequences. Even with all the safeguards, what if an agent modifies its code in a way we just didn't see coming?
Right, and the stakes are higher with Gödel agents because they're constantly learning and changing.
Exactly. And it's not just about the data they learn from. It's about how these systems are managed, what their purpose is. Imagine a Gödel agent that's designed to achieve some complex objective. We have to make sure its actions actually lead to good outcomes, not just any outcomes.
So transparency and oversight are super important. But let's not forget about the potential benefits. What are some of the specific areas where Gödel agents could make a real difference?
Well, like we mentioned earlier, healthcare is a big one. Think about personalized treatment plans or Gödel agents analyzing medical images to detect diseases super early. They could even help design new drugs.
AI helping to cure diseases. Wow.
It's amazing, right? And this is still early days. Who knows what we'll be able to do with these things in the future?
All right, let's dive into the specifics. How are they actually building and training these Gödel agents? What are some of the techniques they're using?
One of the things they focus on is training these agents to achieve very specific goals. It's called goal-oriented programming. Basically, you give the agent a clear objective and let it figure out the best way to get there.
So we're not just letting these AIs loose in the world and hoping for the best. We're giving them specific jobs to do. It's a more advanced kind of machine learning, right?
Exactly. And they go even further by exploring something called meta-learning.
Meta-learning, right. That's about teaching AI to learn how to learn. Pretty mind-blowing stuff.
It is. And it has the potential to really accelerate the development of even more sophisticated Gödel agents in the future.
Right. Starting to grasp the complexity of this technology. But one thing I'm still not clear on is how do these agents actually rewrite their own code? I'm picturing an AI sitting at a computer typing away.
Huh. That's a funny image, but it's not quite like that. The way they describe it in the paper, it's more like a series of small incremental changes, guided by the agent's own learning process.
Okay, so a gradual evolution rather than a sudden rewrite. Can you give me an example of how that might work?
Sure. Imagine an agent that's tasked with, let's say, sorting a list of numbers. It might start with a simple sorting algorithm, but as it learns, it might spot ways to make that algorithm more efficient. So it experiments with little tweaks to its code, testing each one to see if it improves things.
So it's constantly evaluating itself and making adjustments based on what it learns, like a self-improving programmer.
Exactly. And the key here is that the agent is doing all this on its own without any help from humans. It's a truly autonomous learning process.
Okay, I think I'm getting it.
Yeah.
But let's bring it back to the real world for a second. What are some concrete examples of how we might use Gödel agents to solve actual problems?
Well, take autonomous driving, for instance. Imagine Gödel agents designing and controlling self-driving cars that are way more adaptable, more responsive to, all the crazy things that happen on the road.
So instead of relying on pre-programmed rules, these cars could actually learn from experience and become better drivers over time. That's huge.
It is. And it's not just about cars. Think about Gödel agents controlling robots in factories, or optimizing energy consumption in cities, or even managing those complex financial systems.
The possibilities are endless.
Yeah.
But I think it's important to remember that this is all still pretty early stage, right?
Oh, absolutely. We're just scratching the surface. There's so much more to learn and explore.
And speaking of exploring, let's delve a bit deeper into the specific techniques they're using to build and train these Gödel agents. What are some of the key takeaways from the paper?
They really explore a lot of different approaches in the paper, from reinforcement learning to evolutionary algorithms. But what really stands out is how much they focus on creating agents that can handle dynamic, unpredictable environments.
Right. The real world is full of surprises. It's
Yeah.
not enough for these AIs to just excel in a lab setting.
Exactly. They need to be able to adapt and thrive out in the messy, unpredictable real world.
So how do they go about making these Gödel agents so adaptable? What are some of the techniques they use?
Well, one approach is to just, throw a ton of different tasks and scenarios at them during training. The more varied the experience, the more adaptable they become.
It's like giving them a really broad education instead of just specialized training. The more they see, the more they learn.
That's a good way to put it. Another thing they focus on is making sure these agents can learn from limited data. Because in the real world, we don't always have massive data sets for every problem we want to solve.
Right. They need to be efficient learners, able to pick up on patterns and insights from smaller amounts of information. What else are they working on?
One more thing is transfer learning. That's where the AI learns to apply knowledge from one task to a completely different task.
Ah, so instead of starting from scratch every time, it can build on what it's already learned. It's like learning to ride a bike and then finding it easier to learn to skateboard because you've already got some of those balancing skills.
Exactly. And that's what could make Gödel agents so powerful. They could take what they learn in one area and apply it to something completely different, making much faster progress.
Okay, this is all starting to make sense. Can we back up for a second? I just want to make sure I fully understand how these agents actually rewrite their own code. I keep imagining like an AI with a keyboard.
Yeah, no, it's a funny image. But it's not like that. Think of it as more of a series of tiny tweaks, guided by the AI's own learning process.
Okay, so like a constant process of fine-tuning based on what it's learning.
Right. And remember, the agent is doing this all on its own, based on the feedback it's getting from its environment.
That's pretty incredible. It really is like a self-improving programmer. But let's get back to the real world. How could we actually use Gödel agents to solve practical problems?
Well, one example we talked about before was autonomous driving. Imagine Gödel agents designing and controlling self-driving cars that are much more adaptable, much more responsive to, the unpredictable nature of traffic.
Right, so instead of being limited by pre-programmed rules, they could actually learn from experience and become better drivers over time.
Exactly. And it goes beyond just cars. Imagine Gödel agents controlling robots in factories, or optimizing energy use in cities, or even, managing those complex financial systems we talked about earlier.
It's a pretty amazing concept.
Mm.
But we also need to remember the potential downsides.
Mm.
What are some of the challenges that researchers are trying to address?
One of the big ones is ensuring these agents remain predictable and reliable even as they evolve. What if a Gödel agent changes its code in a way that leads to, unpredictable behavior?
That's a scary thought. So how do we make sure that doesn't happen?
That's what a lot of this research is focused on. They're exploring different ways to bound these agents, like we talked about earlier, to make sure they stay within safe limits. And they're also working on ways to make them more transparent so we can understand why they're making the decisions they make.
So it's not just about making them smarter. It's about making sure they're safe and understandable. Well, you've definitely given us a lot to think about. I'm starting to understand why there's so much buzz about Gödel agents in the AI community. It's like a whole new frontier.
It really is. And this paper gives a great overview of this complex and rapidly evolving field.
Okay, so now that we've got a good handle on what Gödel agents are and how they work, I'm ready to dig a little deeper. Let's look at some of the specific techniques they're using to build and train these things. What stands out to you?
What fascinates me is the sheer variety of approaches they explore, especially when it comes to that whole bounding thing. They go into quite a bit of detail about the different methods, each with its own pros and cons.
Okay, let's break those down one by one. I'm ready for the nitty-gritty. Where do we start?
Let's begin with what they call resource bounding. This is where you limit the computational resources, like processing power and memory, that the agent has available.
Right, so it's like giving them a limited budget. Makes sense. What else is in their toolbox?
Another interesting method is action bounding. This technique restricts the actions that the agent is allowed to take within its environment.
So we're putting limits on what the AI can actually do, as well as how much it can change itself. That's good.
And then there's performance bounding, which we've touched on before. That's where you tie the AI's freedom to modify its own code to how well it's performing.
So it's like a reward system with built-in checks and balances. If the AI is doing well, it can experiment more. But if it starts screwing up, we rein it in. It's like we're saying, hey, AI, you can try new things, but don't mess it up.
Precisely. But these bounding techniques are only part of the story. The paper also delves into some really interesting discussions about the broader implications of this technology and how they're being addressed in their research.
Okay, let's go there. Because I think a lot of people hearing about self-rewriting AI are probably having some what-if questions popping into their heads. What are some of the key concerns that the paper addresses?
Well, one of the major issues they highlight is the potential for unintended consequences. Even with all the safeguards in place, what if a Gödel agent learns from data that reflects the complexities of the real world and its evolution leads to unexpected repercussions?
Right. We've already seen AI systems encountering unforeseen challenges in the real world. And with Gödel agents, the stakes are even higher because they're constantly learning and changing.
Absolutely. And it's not just about the data they learn from, it's also about how these systems are managed and what their intended purposes are. If we have a Gödel agent that's designed to achieve a complex objective, we need to make sure its actions are truly aligned with the desired outcomes.
Okay, so transparency and oversight are crucial. We need to be able to see how these systems are making decisions and what measures are in place to ensure responsible outcomes. But let's not forget about the potential benefits. I'm curious to hear more about the specific applications of this technology. Where could Gödel agents really make a difference?
Well, as we mentioned earlier, healthcare is a prime example. Imagine Gödel agents designing personalized treatment plans for patients, analyzing medical images to detect diseases earlier, or even developing new drugs and therapies. They could completely change how we approach healthcare.
And it's not just healthcare, right? I could see these agents being used in any field where complex decision-making and problem-solving are essential. Finance, education, transportation, environmental science. The possibilities seem endless.
They really do. But I think it's important to keep in mind that this is still a very young technology, and we have a lot to learn about how it will develop.
Okay, I'm ready to delve deeper into the actual research. What are some of the specific techniques and methodologies they use to build and train these Gödel agents? Walk me through it.
Well, one fascinating aspect is their focus on training Gödel agents to achieve specific objectives. They use a method called goal-oriented programming, where the agent is given a clear goal and then allowed to experiment and learn how to achieve it.
Okay, so we're not just throwing these agents into the world and hoping for the best. We're giving them specific tasks and letting them figure out the most efficient way to accomplish them.
Exactly. It's about empowering them to learn and adapt on their own. And they take it even further by exploring the use of meta-learning, where the agents are trained to learn how to learn.
Whoa, that's next level. So we're not just teaching these AIs to be good at certain tasks. We're teaching them to become better learners overall.
That's right. It's a really intriguing area of research, and it has the potential to accelerate the development of even more sophisticated Gödel agents in the future.
I'm starting to get a sense of the complexity and potential of this technology. But one thing that's still a bit fuzzy for me is how these agents actually rewrite their own code. I keep picturing an AI hunched over a keyboard, like a programmer.
That's a fun image, but the process is a little more abstract than that. In the paper, they describe code modification as a series of incremental changes, guided by the agent's learning process.
Okay, so it's more like a gradual evolution of the code rather than a complete rewrite all at once.
Exactly.
Can you give me an example of how this might play out in practice?
Sure. Imagine a Gödel agent that's been tasked with sorting a list of numbers. Initially, it might start with a very basic sorting algorithm, but as it learns, it might identify areas where the algorithm could be improved. It might then experiment with different code modifications, testing each change to see if it leads to a faster or more efficient sorting process.
So it's constantly evaluating its own performance and making adjustments based on what it's learned, like a self-improving programmer.
Precisely.
Okay, I think I'm starting to wrap my head around this, but let's bring it back down to earth for a minute. What are some concrete examples of how Gödel agents could be used to solve actual real-world problems?
Well, we talked about autonomous driving earlier. Imagine Gödel agents being used to design and control self-driving cars that are much more adaptable and responsive to all the complexities of traffic.
Okay, so we're talking about cars that can actually learn from experience and become better drivers over time. That could be a game changer for safety and efficiency.
Exactly. And the applications go way beyond just cars. Imagine Gödel agents controlling robots in factories, or optimizing energy consumption in smart cities, or even managing complex financial systems.
The potential seems enormous.
It really is. And that's what makes this research so exciting. It feels like we're on the cusp of a major breakthrough in artificial intelligence.
But as we've discussed, it's important to proceed with caution, right? There are potential downsides to this technology as well.
Absolutely. And the researchers are very much aware of that. They dedicate a significant portion of the paper to discussing the potential risks and the steps they're taking to mitigate those risks.
Okay, good. Because I think a lot of people hearing about AI that can rewrite itself are probably wondering if we're opening Pandora's box here.
It's a valid concern. But the researchers are approaching this with a great deal of responsibility, emphasizing the importance of safety, transparency, and ethical considerations.
Well, that's reassuring. But before we move on, I want to make sure we've got a solid grasp of some of the key techniques they're using to build and train these Gödel agents. What are some of the main takeaways from the paper?
One of the things that really stood out to me was their focus on training these agents to operate in dynamic and uncertain environments. They're not just building AI that can excel in a controlled lab setting. They're building AI that can thrive in the messy, unpredictable, real world.
Right.
And they're using a variety of techniques to achieve this, from training them on a wide range of tasks to incorporating mechanisms for them to learn from limited data.
Okay, so it's about making them as adaptable and resilient as possible.
Exactly, because the real world is full of surprises, and we need AI that can handle those surprises gracefully.
Well said. I'm definitely starting to see why this research is generating so much excitement.
Yeah.
It feels like we're witnessing the birth of a new era in artificial intelligence.
I agree. And this paper is a great starting point for anyone who wants to understand the complexities and potential of this groundbreaking technology.
I'm eager to delve even deeper into this research. But I think we've covered a lot of ground in this first part of our deep dive. We've explored what Gödel agents are, how they work, and some of the key challenges and opportunities they present.
And we've only just scratched the surface.
Exactly. I can't wait to see what other insights we uncover as we continue our exploration. But for now, let's take a break and come back refreshed for the next part of our deep dive. We'll pick up where we left off and explore some of the specific techniques being used to build and train these remarkable Gödel agents.
Sounds good to me.
See you on the other side.
See you then. One of the things that really struck me about this paper is how elegant these Gödel agents are. It's like they took inspiration from the very nature of intelligence itself.
Okay, I'm intrigued. Break that down for me. What do you mean by elegant?
It's all in their structure. They've got this modular design where the agent is made up of these separate components that work together, like a well-oiled machine.
So instead of one big AI brain, it's more like a team of specialized experts, each handling a different part of the problem.
Exactly. Let's start with what they call the perception module. This is like the AI's senses. It takes in all the information from the environment. Could be sensory data, text, images, whatever the agent needs to work with.
Got it. So the perception module is all about gathering intel. What happens next?
That information gets passed on to the reasoning module. This is where the magic happens. The reasoning module analyzes all that input, makes decisions, figures out the plan of action. It's like the AI's strategic command center.
Okay, so we've got the perception module gathering data, the reasoning module making decisions. But how does the agent actually put those plans into action?
That's where the action module comes in. This part takes the decisions from the reasoning module and translates them into real-world actions. It's the AI's hands and feet, so to speak.
I see. So perceive, reason, act. Pretty straightforward. But what about the whole self-modification thing? Where does the code rewriting happen in all this?
That's the really cool part. It's handled by the self-modification module. This module can actually access and change the code of the other module, so it's like the agent is tweaking its own programming as it goes.
Whoa. Okay, that's pretty powerful. But as we discussed earlier, it's also where things could get a bit risky.
Right. That's why they spend so much time in this paper talking about bounding, about making sure this self-modification happens within safe limits.
It's like giving the AI a toolbox, but making sure it only uses the tools responsibly.
Precisely. Now let's talk about training. How do we actually teach these Gödel agents to do what we want them to do?
Yeah, I'm curious about that. It's not like we could just send them to school, right?
Well, not exactly. Although they do talk about something called curriculum learning, which has some interesting parallels to how we humans learn.
Okay, I'm all ears. Tell me more about this curriculum learning.
Basically, you start by giving the agent simple tasks and then gradually increase the complexity as it learns. Just like in school, you start with the basics and then move on to the harder stuff as you progress.
So we're not throwing these AI agents into the deep end right away. We're giving them a chance to learn and grow at a manageable pace.
Exactly. And this approach has been really successful in training Gödel agents. It helps them develop a more robust understanding of whatever domain they're working in and gives them a more sophisticated set of problem-solving skills.
Makes sense. A strong foundation is important for any kind of learning, whether it's for AI or humans.
Absolutely. And beyond curriculum learning, they also explore other techniques like meta-learning. This is where things get really interesting.
Meta learning, right. We talked about that before. It's about teaching AI to learn how to learn, not just to perform a specific task.
Precisely. Instead of just training an agent on, say, playing chess or sorting numbers, we're teaching it to learn how to learn any task more efficiently.
So it's like instead of just teaching the AI to fish, we're teaching it to build its own fishing rod.
Ha! I love that analogy, and that's a big part of what makes Gödel agents so potentially transformative. They have the potential to be lifelong learners, constantly adapting and getting better no matter what challenges they face.
Okay, so we've talked about curriculum learning and meta learning. What other tricks do they have up their sleeve when it comes to training these Gödel agents?
Another interesting one is imitation learning. Basically, this involves letting the agent learn by watching and copying how humans solve problems.
So it's like an apprenticeship for AI.
Yeah.
Like, watch me, young Padawan, and learn.
That's exactly it. And it's especially useful in situations where it's hard to come up with clear-cut rules or objectives for the AI to follow. Instead of trying to program every possible scenario, we can just show it examples of how humans do it and let it learn from those examples.
That makes a lot of sense. Humans have been learning by imitation for centuries, so why not apply the same principle to AI?
Exactly. And it's been pretty effective. For example, in robotics, imitation learning has been used to teach robots to do all sorts of complex things, like grasping objects or moving through cluttered environments, all by watching humans do it first.
So these Gödel agents aren't just learning from data, they're also learning from human expertise. That's a pretty cool blend of human and artificial intelligence.
It really is, and it's one of the things that makes this research so exciting. It's not just about creating AI that's better than humans. It's about creating AI that can learn from humans and collaborate with us more effectively.
Well said. Okay, we've covered a lot of ground here, from the structure of Gödel agents to the different ways they can be trained. But I want to circle back to something you mentioned earlier, the idea that these agents could potentially operate in really dynamic and uncertain environments. The real world is messy and unpredictable.
Right, exactly. And we need AI systems that can handle that can adapt and thrive even when things don't go according to plan.
So it's not enough to have AI that can excel in a lab setting. We need AI that can handle the chaos of the real world.
Absolutely. And that's where things get really challenging. Traditional AI systems often struggle when they encounter situations that are different from what they were trained on. They can become brittle and unreliable.
So how do researchers address that? How do they make these Gödel agents more robust and adaptable?
One approach is to build randomness and variability into the training process. So instead of training on a fixed set of data, they expose the agent to a wider range of scenarios, including unexpected events and noisy data. This helps it develop a more generalized understanding of the problem, so it's not so easily thrown off by unexpected situations.
So it's like giving the AI a crash course in dealing with the unexpected.
Exactly. And it's not just about the training data, it's also about designing the agents in a way that makes them inherently more adaptable. For example, using techniques from reinforcement learning, where the agent is constantly learning and adjusting based on its interactions with the environment.
So instead of relying on pre-programmed rules or a fixed set of knowledge, it's constantly learning from its experiences and adapting its behavior.
Precisely. And that ability to learn and adapt on the fly is crucial for operating in those dynamic, uncertain environments we talked about.
Makes sense. The world is always changing, so our AI needs to be able to change with it.
Right. And that's what makes this research so exciting. It's not just about creating smarter AI, it's about creating more resilient, more adaptable AI. AI that's, in a way, more human-like in its ability to learn and evolve.
Well said. You've given us a lot to think about, but I'm eager to dive a little deeper into the specifics of this research paper. What are some of the key findings that really jumped out at you?
One of the things that impressed me the most was just how wide a range of problems they've been able to apply these Gödel agents to. Everything from optimizing complex logistics systems to designing new materials with specific properties. They're proving to be really versatile.
So it's not just hype. These Gödel agents are actually showing real potential to solve real-world problems.
Absolutely. And I think we're just scratching the surface. As this technology keeps developing, I think we'll see even more impressive applications.
That's exciting. But as always, we need to be mindful of the potential downsides as well. What are some of the risks that we need to keep in mind as we move forward with this technology?
Well, one concern is that these agents could become so complex that we don't really understand how they work anymore. They could become a black box where we can't see the reasoning behind their decisions.
Right. That's a classic problem with AI. We need to make sure that we can understand and trust these systems, even as they get more sophisticated.
I agree, and that's something researchers are working on. They're developing techniques to make Gödel agents more transparent so we can see how they're making decisions and intervene if necessary.
That's good to hear.
Mm.
But transparency is only part of the issue, right? We also need to worry about potential misuse. What if someone uses this technology for harmful purposes?
That's definitely a risk that we need to take seriously. Any powerful technology can be misused, and Gödel agents are no exception. So it's crucial to have safeguards in place to prevent that. Things like security protocols, ethical guidelines, maybe even regulations to govern how this technology is developed and used.
So it's a multifaceted challenge. It's not just a technical problem, it's a societal problem as well.
Exactly. And that's why it's so important to have these conversations now, to think about the ethical implications and potential risks as we develop this technology.
Well said. This deep dive has been fascinating. It really feels like we're on the cusp of something truly revolutionary with these Gödel agents.
I agree. It's a technology with immense potential, both for good and for potentially bad. It's up to us to make sure we use it wisely.
Okay, I think we've covered a lot of ground today. We've explored the inner workings of Gödel agents, their potential applications, and some of the ethical considerations that are essential to keep in mind.
We've only just scratched the surface, though. There's still so much more to discover and explore.
And speaking of exploring, I'm ready to dive into some specific examples of how Gödel agents are already being used to solve real-world problems. Let's take a look at how this technology is already making a difference.
Sounds good to me. So we've talked about the potential of Gödel agents, but let's not forget the challenges. One of the big ones is how to keep these self-modifying AIs under control. That's where bounding comes in.
Right, bounding. We've touched on that a bit in the previous parts. Essentially, it's about making sure these Gödel agents play by the rules, that they don't rewrite themselves in a way that could be harmful.
Exactly. It's about giving them freedom to innovate, but within a safe, controlled environment.
So how do researchers actually go about implementing these boundaries? What are some of the techniques they're exploring?
Well, one approach is called resource bounding. That's where you limit the computational resources that the agent has access to, things like processing power and memory.
We talked about that before, right? It's like giving the AI a budget that can only make so many changes before it hits its limit.
Right. Another method is action bounding. Here, you restrict the types of actions the agent can take within its environment.
So if the Gödel agent is controlling a robot, for example, we could restrict its movement or prevent it from interacting with certain objects.
Exactly. It's like setting up virtual fences to keep it from going where it shouldn't.
Makes sense. What other techniques are they using?
They also discuss something called performance bounding. This is really interesting. It links the agent's ability to modify its code to how well it's doing on a given task. If it's performing well, it has more freedom to experiment. But if it starts messing up...
You take away its coding privileges. It's like we're saying, hey, AI, you can try new things, but if you start screwing up, we're putting you on restriction. It's an interesting way to encourage both innovation and responsibility.
Exactly. It's a balancing act. And then there's the more traditional approach of human oversight, where a human expert keeps a close eye on the agent's actions and code modifications.
So it's like having a mentor or supervisor, making sure the AI doesn't go off the rails. But wouldn't it be incredibly challenging for humans to keep up with these systems as they become more complex?
That's a great point. And it leads to another fascinating idea they explore in the paper, the concept of AI guardians.
AI guardians. That sounds like something straight out of science fiction. What are they?
Think of them as specialized AI systems that are specifically designed to monitor and control the behavior of other AIs, including Gödel agents. They're like digital watchdogs trained on huge data sets of human values, ethical principles, and safety protocols.
So we're talking about AI policing other AI. That's pretty wild. How would that actually work?
These AI guardians would constantly be monitoring the actions and code modifications of the Gödel agents under their supervision. If they detect any behavior that deviates from the established guidelines, they could step in, prevent the Gödel agent from doing anything harmful.
That's incredible. It's like a built-in ethical compass for these powerful AI systems. Are there any other safeguards they discuss in the paper?
Yes, they also talk about the concept of value alignment. This focuses on designing Gödel agents from the very beginning with human values and objectives embedded in their core programming.
So it's not just about setting external limits. It's about making sure these AIs are fundamentally aligned with our values and goals.
Right. It's like raising a child with a strong moral compass. You want to instill those values early on so they'll make good choices even when you're not around.
That's a great analogy. It's clear that researchers are taking the ethical considerations very seriously, exploring a lot of different approaches to make sure these Gödel agents are developed and used responsibly.
Absolutely. It's an ongoing process, of course. There's still so much we don't know about these systems and how they'll evolve. But it's encouraging to see that researchers are putting so much thought and effort into ensuring that this technology is used for good.
Well, this deep dive has been an incredible journey. It feels like we've only just begun to explore the possibilities, but it's clear that Gödel agents have the potential to be truly revolutionary.
I agree. It's a technology that could change the world in profound ways, but it also demands careful consideration and a deep understanding of both its potential benefits and its potential risks.
We've covered a lot of ground in this deep dive, from the technical details of how Gödel agents work to the broader ethical and societal implications of this technology. I think we've given our listeners a lot to ponder, but one thing is clear. Gödel agents are a powerful new tool in the world of artificial intelligence, and their development will undoubtedly have a profound impact on the future. So, to everyone listening out there, stay curious, stay informed, and stay engaged in this crucial conversation about the future of AI. Thanks for joining us on the Deep Dive.
Thanks for having me.